All right, so now we are going to, compare decimals. And the nice thing is that this is really a continuation, right? Like we do the same thing. We set up a place value chart. We look in the biggest place because the biggest place has the most value, right? But there's one other big idea that we tend to emphasize a little bit more with decimals. So let's see if you can name it before me as you watch this video. And then remember again, this big idea is both helping us do this work and we'll carry it through to the next constructed response lesson. Earlier this year, we learned to compare decimals in 2 ways. See if you can turn and tell your partner in both ways. See what they can say. Hopefully someone brings up the same big idea that you've been reviewing the last 2 days, right? We can look in the biggest place. Be careful, right? Like it's not enough to just say one way we can do it is to line them up, right? Get to that big idea. We do line them up, right? 0.24, 0.5, and one way is to look in the place to the left, the biggest place, because it has the highest value, and this has more tenths than this one, right? Another way is to add a 0 and to say that 50 hundredths is bigger than 24 hundredths, right? And when we do that, we write, the big idea there, right, is that we're writing 5 tenths in a different form so that it has the same, right, number, it has the same value as 24 hundredths. So that we're comparing hundredths with hundredths. So that's the big idea. That's another way we can compare 50 is more than 24. Great. So today we're going to practice just one of the ways to make sure we've got it. And so you're going to really actually, it erases. You're going to really emphasize that equivalent form way. And the reason I picked that way is because I think that's the one that most kids are using at the end of the day. What do you think our work should look like? Let them tell you, place value chart, and then, right, you're doing your chart. 3 tenths, looks like that. 41 hundredths, looks like that. We're going to just focus on the putting the 0 away, right? What does a good explanation sound like? I changed, and now listen, it's so funny. I changed 3 tenths into 30 hundredths. 41 hundredths is bigger than 30 hundredths. So 41 hundredths is bigger than 3 tenths. That's the procedure. What is the big thing? Like, what is it that allowed us to even do this procedure? Right? Why is it we could do that? Well, we changed 3 tenths into an equivalent form that had the same value as 41 hundredths. So was looking at the same places as 41 hundredths, hundredths with hundredths. Right? That's the big idea. So keep coming back to that because you know what's coming up in that constructed response. But then we're really focused on doing this work because I think we've taught it so many different ways that procedurally this has been confusing for kids too. And I just want to have one way that we're practicing on this to make sure that we're getting these all right. These should be slam dunks and they're not yet. So now, this problem and this problem are just like different forms of the same thing, but again, here focusing on like the work, right? If I do this, I should have a double place value chart. So I should have a place value chart for this one, right, where I have 0.8 and I have 0.08. I need a place value chart for this one. And just really emphasizing like the thoroughness of the work, right, for all of these problems. It's one problem. It looks like it should be like, I'll just do it in my head. Do it in my head. No. Again, we show our double place value chart for every single problem. And so then you just get into the IP and exit ticket. The IP is a lot of practice like that. I'm just going to go into the next day because the next day is writing constructed responses about this. And that big idea that we talked about, there's the one that we can still use. Look in the leftmost place. It has the biggest value. It's going to be bigger than all the other values, so we look there. Or a new one, right, which is I can turn a number into an equivalent form that has the same values as the other, and then it's going to be easier to compare. That's the big idea, right? Because remember what we talked about here, right? That's what we're looking for to take a constructed response from 3 to 4. And then, of course, you've got your other little pieces of feedback that you'll be using for kids at other levels. So let's dive in. When we write constructed responses, we will either be asked to justify our thinking or correct someone else's thinking. Now, this is a little bit different than whole numbers, right? Because for this one, for whole numbers, we just had to reason about the place value system itself, right? For decimals, here they give us 2 evidence statements. One says, base explanations or reasoning on concrete reference, such as a diagram, whether provided in the prompt or constructed by a student, and relate diagrams to equations. So in other words, I am having to justify my reasoning, construct an argument, and I have to use the concrete referent. Or this one, distinguish correct reasoning from that which is flawed and correct the flawed reasoning. So I'm being told something is wrong, and I have to explain why it's wrong, right? So this is a little bit more tricky than the whole numbers one. We're going to kind of do 2 cycles. First, when we justify our thinking. To justify our thinking, we want to refer to an imaginary picture or number line. And we still want to hear that big idea when we're talking about our picture or our number line. Right? And then what kind of words do you think we'll use? And so just being clear here, right? Like I'm going to talk about tenths. And I'm going to use the word hundredths. And I'm going to use the word equivalent, right? Because that's come up in my big idea. I'm going to refer to the picture and talk about cutting pieces. Right? Sorry. Awesome handwriting, Lisa. So, then, you are not going to talk through this response as a group. You're going to give this to them, let them work, do a show call, have, put some student work up, discuss it, right? Add the main idea if it isn't there yet. One of the conversations we'll have in the meeting, and something you should bring to the meeting, is what is an exemplary response? Right? When they say explain how you can use the grids to compare 2 decimals, sorry. They don't just mean these 2 decimals, 0.2 and 0.17. They mean any decimals. So what I say about this, I want to have a sentence where I'm like, you can always change tenths into hundredths and have it in an equivalent form so that then it's easy to compare hundredths with hundredths. You see how that big idea can be something that shines through. I can say it at the start. So, to shade 0.2 on square A, I shared 2 pieces, right? To shade 0.17 on square B, I shade 17 pieces. But now, just like 0.2 can become 0.20, on my shape, I would cut each of my tenths into 10. That would give me 20 hundredths. So I hope you hear here. There's a balance between describing the procedure as well as saying the big idea. And both of those connect back to my concrete referent. Let them try this one. Do a show call, put someone's example. It's going to be the same big idea. Oh. No, in this case, I'm so sorry. The big idea is going to be that we look in the leftmost place. We look at those tenths because they're bigger than hundredths. And my number line shows, right, that one is so much bigger than the other. This is going to be a lot of time on the carpet. The reason I feel comfortable with it being so much time, it's 4 constructed responses on this PowerPoint. The reason why I feel comfortable with that is because it's going to be broken up by student work. So instead of having just a really long IP, it's like everyone works for 5 minutes. Everyone talks for another 5 minutes. I don't mind if you have them actually move, literally, desks, carpet, desk, carpet, desk, carpet. That's fine. But that is how we get through lots of examples and are continuously improving them. Next thought, when we write constructed responses, again, we're either going to justify our thinking or correct someone else's thinking. To correct someone else's thinking, we want to use the same words we talked about earlier. We also need to make sure we explain why the person is wrong, not just what they should have done differently. So over here in this example, it's not enough to say, Eliza should change 0.3 into 30 hundredths. And then her pea plant would be taller than her tomato plant. Right? That's just telling what she should have done. It doesn't explain what it is she did and why that's wrong. Now, teachers, I'm explaining that to you. I don't want you to explain that to them. Same format. I want you to let them work for 5 minutes and then discuss it for 5 minutes. But your question needs to be, did they actually talk about the error? And the error in this case is that Eliza just used the digits she saw, 24 and 3. But that 24 and 3 don't have the same value. And when we compare, we have to compare like values. Did you hear the big idea in my correction? When we compare, we have to compare like values. Eliza didn't compare like values. She should have changed 3/10 into 30 hundredths, and then she could have compared hundredths with hundredths. 30 hundredths is more than 24 hundredths. I know these are doozies. Here's one more, get to the big idea. We can talk through a lot of these exemplars, but the basic structure is going to be introduce type, practice, practice. Introduce type, practice, practice.